All right then. So now we're gonna do example number 3. What I'm gonna do here is I'm not gonna solve it to the final answer because I'm a little bit struggling with this, especially with my writing. Just don't wanna waste time. I'll just give you. I'll just solve. I'll just solve it to where you need it. Okay, which I believe you can continue from having a look at example number 2, but we'll see. So now here, what we have here, we have the differential equation. We need to solve it by determining the general solution. Again, we don't have the conditions to determine the particular solution. So again, what we're going to do here is we're going to have to determine the nature of roots using the auxiliary equation. So here we have m squared minus 4m plus 4, which will be equals to 0. Remember, we take it here, we take it there. And therefore, now let's factorize this. The factors, we're going to have m, we're going to have m, right? And then the factors there, we're going to have 2, we're going to have 2, negative and negative. So that means our m is going to be equals to 2, and or another m is going to be equals to 2. So we have m1 and m2, but we can see that both m1 and m2 are both the same. So in this case, what you're going to do, you're going to determine the particular, the characteristic solution, characteristic equation or solution. So to determine the characteristic equation or solution, remember when we have equal roots like this, we have a multiplied by our independent variable, which is x, plus b to the power of multiplied by e to the power of m is the same throughout. So it's going to be m to the power of x, which is our independent variable in this case, right? So now, again, the most important thing that you need is this one. How are we going to determine the particular solution? Integral. So determine particular integral, we use y is equals to a. Again, remember, it's either you use this to x, or you use this. If this doesn't work, you use this. Right? You just add x. You just multiply by x. If this doesn't work, you use this. X squared e to the power of 2x. It's either you use one of the guys, right? If this doesn't work, you use this. If it doesn't work, but you saw the thing is, you can, guys, you cannot substitute this and try to work them out to see if this is gonna work. Do that when you practice alone. But in your exams, in your tests, don't do this. Don't test these trials. There is nothing wrong with you doing that. It's just that you're not gonna get done. You're not gonna complete your paper. You're gonna stuck only in one question, about 30 minutes or so. Okay, so which one are we going to stick with, this, or are we going to stick with this, or are we going to stick with this? We want to check, right? Remember what I say to you, you go here, you check if e to the power of 2x appears on the characteristic equation. This is our characteristic equation. So we can see that we have e to the power of 2x, we have t e to the power of 2x. So what are we thinking in our minds? We are thinking of this. We can use this one, right? This is the one that we can use. But be careful, because here, if I have to distribute this thing inside, I'm going to have a x multiplied by e to the power of 2x, and then I multiply this one over here. I'm going to have b e to the power of 2x. So this appears over there. It also appears over there, but it appears with x, right? So when it appears twice, or when it appears x e to the power of 2x, and then e to the power of 2x, it appears on the characteristic equation. Therefore, this is the one that we're actually going to stick with, not this one, okay? We don't look it over here. We have to distribute inside of the brackets. So that means this is the one that we're gonna use. Stick with this special case over here. We're gonna stick with the third one. So that's why here they say to us, when e to the power of ax and x e to the power of ax both appears in the characteristic equation, therefore we're gonna use this where now we have x squared. We no longer have x, but we have the x squared. So always take note of that, okay? So that means in this case, what you're gonna do is, we don't have to try everything. Then we're gonna have to do that. And then the procedure is the same throughout. So this is actually what I want to show you, okay? By not solving, this is gonna be long and I might make mistakes, and I'm not enjoying writing on this thing. So that means we have y is equals to a, can I take x squared, because this and this, which is the same as that, appears on the characteristic equation. That's why we have x squared e to the power of 2x. We're going to have to determine the first derivative. We're going to have to determine the second derivative. And therefore, after that, we're going to substitute there. We solve for value of a. And then after solving for value of a, what are we going to do? We come back again here, we determine the particular integral, knowing the value of a. And therefore, we're going to say this equation plus this equation will give us the general solution. Okay, so if you follow number 2, you'll understand how to go about for this equation as well. And thank you very much.